Well, hello. Happy Freya's Day. Hope you're doing well. So if you felt like our last double lesson kind of went like, what just happened? Our book has graciously offered us another try. So we're going to just continue working those big ideas, what I'm dealing with when I'm adding or subtracting mixed numbers. Now, here our first problem is 1 3/4 plus 2 1/8. Now, things we want to think about is always, whenever adding and subtracting mixed numbers, I need to focus in on those denominators and make sure that they are common. I see here that they are not. Now, when I add mixed numbers, I don't require stacking. What I do require is our ability to kind of be able to take something like 3/4 and transform it into a fraction that will have a shared denominator. And whatever work you need to do to get there, work on the side, do it. However, I believe that at least some of us can know that this 3/4 would easily become 6/8. And once I have that, I'm not doing anything to this 2 1/8. I have a shared denominator, so I can focus in and go, okay, so 1 plus 2 is clearly 3, and then 6/8 plus 1/8 is 7/8. Now, I'm not showing a lot there because I don't require any showing beyond what you see. However, if you are needing still to show work, such as that 3/4, times this, blah, 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 is equal to something of 8, well, then you should show that work, whatever you need. But I do need what you see here. Like, I'll circle it in blue. This is what I would need. Let's continue on. Here we've got a subtraction problem. And remember, like, let's say you saw this in your book, and again, my influence is only lasting a few more days, but I don't mind if you see this in your book, but you immediately go into the structure that we're going to do whenever subtracting mixed numbers, which is clearly that we're going to stack them. So I take that 4 1/2 and I stack the 1 1/3 below it. Now, immediately then, I should think about my denominators. I've got a 2 and a 3. They are not shared. So I then have to do whatever work necessary to go, okay, what's their LCM? What's their LCD? But hopefully you're getting to the place that you're like, oh, well, I know that this is going to be 4 3/6. And I know that this 1 1/3 is 1 2/6. So again, if you need to show. If you can do just this, then just do this. Because you see, I've solved my problem. I now have shared denominators. There's no worry in me subtracting 2/6 from 3/6. So I'm just go ahead and do that. So I've got shared denominators. I got to worry about that 3 and 2. 3/6 minus 2/6 is clearly 1/6. And then I'll do my whole numbers. 4 minus 1 is 3. Nothing to reduce. I can box that baby up. Yeah? Okay. Hopefully we're doing good. We got more. Here's another one. So again, if you saw this in your book in a horizontal fashion, I have no problem with the first thing I see written on your tests or on your homework would be the stacking, because that's how I always want you to deal with subtracting mixed numbers. And again, even if someone tells you later on, oh, you don't have to do that, I just say do it. And the reason why is over the years, kids, I have found that people are more successful when they do so. I also am not showing another method that maybe a tutor or an older person might show you, maybe even your next year's teacher. I encourage you to stay away, friends. I promise you, I've got data. Now, immediately, when I look at my 6 and my 2, I see that I have uncommon denominators, so I'm going to have to work on that. Now, 2 and 6, maybe I just need to do some work there, but I know the 6 and 5/6 is not going to happen. But if I need to do some work on that 1/2, or maybe I know, oh, well, isn't that going to be 2 and 3/6? Kind of depends on your level, right? Where are you at? Then I see that my problem is solved because I've got shared denominators. So I just worry on the 6 minus 3/6, and I get 2/6. 6 minus 2, 4. Now, please don't box this up. We have been working hard all year for you to realize that 2/6 is something that can be reduced. Therefore, you want to reduce it. We do know that the GCF is 2, so if you need to write this out, go ahead. If not, you could go directly to your answer and name it as 4 1/3, and that is something that can be boxed. Oh, you guys are doing great. I feel like a pro just because I'm near you. Hey, let's do this one. 5 1/3 minus 2 3/4. Guess what? It's subtraction. Let's stack. Boop, 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 boop. Let's focus on our denominators, 3 and 4. Now again, if you need to list it. List that thing to prove to yourself that the LCM, thus the LCD, is 12. Then if you need to write stuff out, like I said before, we'll write it out. So you'd say, okay, 1/3 times something of 12. That's going to be 4/4, right? So I'll say 4/12. So I'll rename 5 and 1/3 as 5 and 4/12. Again, if you need it. Here, this 2 and 3/4, same sort of thing. If you need it, 3/4 times, what would that be? It would have to be 3/3, right? So I end up with 9/12. So this is 2 and 9/12. Now here's where that borrowing and regrouping. And again, I really encourage this method that we've talked about. I cannot take 9/12 from 4/12. So what do? I'm going to borrow from this 5. I'm going to borrow 1. Then I'm going to think about, okay, I'm going to make that 1 equal to 12/12. And again, I don't require you writing that, but I do require you taking that 12/12 and adding it to the 4/12. And you end up with 16/12. Then I just bring this 2 and 9/12 over. Now that I've got shared denominators, I just worry about 16 minus 9, which is 7. And then 4 minus 2, 2 and 7/12. Yeah? Kind of cool, huh? So a method I'm not a fan of. And I'll tell you about it real quick. So it'd be something like this. 2 and 1/2 minus, let's say 5 and 1/3. Not 1/3/4. All right. So again, this is what some people will do. They'll turn this into an improper fraction. You get 5/2. And then they'll turn this into an improper fraction. Oh, we're subtracting. And so 5 is 23/4. Then they deal with their shared denominators, and they're like, okay, so that's going to be 10. Oh, everything's wrong here. Everything's wrong. Wrong. Sorry. 5 and 3/4 is less. So what if we did 1 and 3/4? And so, okay, what they'll do is they'll turn these into improper fractions. So you got 5/2, and then here I'd get 1 times 4 is 7, 4 plus 7, 7/4. Then they'll deal with this, that they have unshared denominators, and they end up with 10/4. And then they say 7/4, and then they subtract. And you go, oh, okay, 3/4. Now, again, you might go, well, what's the problem with that method? Well, here's the problem. I mean, 2 and 1/2 and 1 and 3/4. What if I give you like 17 and 5/6 minus 15 and, let's go with 9/17? So that method, you really want to take the time to multiply 17 times 6 and then add this 5? And then you're going to have to deal with, one, computational potential errors here. Then the same here, 15 times 17 plus 9, computational errors potential. Then we'd have to deal with the fact that we didn't have shared denominators. So you're going to have to deal with that. More potential computation errors happening. And then there's going to be the subtraction. And then the craziest thing is that method requires you then to now put it into mixed number form. It's not a good process. So, friends, countrymen, this is your way. And I've been doing this for years and years and years, and all I can tell you is it breeds success. So stack when subtracting, show any necessary work for you, and do your best. So it is phrase day, so obviously I'm not giving you homework, but we are almost there. Oh my gosh, I can hear L113 at the door. At the door. You're going to finish because of your hard work. Thanks so much. Take care. Bye.